Polonium-210 is described as extremely toxic. It is one of the most dangerous radioactive toxins to humans. By weight, polonium-210 is approximately 250,000 times more toxic than hydrogen ammonium. Just 1 microgram, or 1 millionth of a gram, is far too much to kill a pepper grower. In fact, it is believed that 1 gram of polonium-210 is enough to kill 50 million people and, incidentally, sicken another 50 million. In other words, you only need 160 grams of polonium-210 for all 8 billion people on Earth. Hello, it's great to see you again in this video. Now we'll answer the question, by what mechanism does radiation emitted from radioactive substances harm the human body? Which form of radiation is most dangerous to humans? And what would happen if it were used as an assassination weapon? Let's begin. The harmful potential of the 3 common types of radiation emitted from radioactive substances is alpha, beta, and gamma. Generally, it depends on their penetration and ionization capabilities. In terms of penetration, alpha radiation is the weakest. Then comes beta radiation, and the strongest penetrating radiation of all is gamma radiation. While just a few centimeters of air are enough to block alpha radiation or alpha particles. A 1 millimeter thick sheet of aluminum or several meters of air will block electrons and beta radiation, while it would take several centimeters of lead metal or 1 meter of concrete to block most gamma rays. Because gamma rays are essentially high-energy photons that don't carry any electrical charge, they don't interact strongly with atoms. It's like 2 rivers not interfering with each other electrically, like 2 rivers not mixing. Therefore, it can penetrate large gaps between layers of material. When gamma rays come into contact with the human body, they cause damage at the cellular level and have the potential to penetrate, causing widespread damage throughout the body. However, precisely because they are not purely electrically charged, they interact less with matter and therefore cause less ionization than alpha and beta particles. I often hear about ionization. So what exactly are ions and what is ionization? The cells and tissues that make up our bodies are built upon even smaller units called atoms and molecules. These atoms and molecules are electrically neutral. This means that if you add up the charges of all the constituent particles, their total is 0. When an atom is ionized, it gains or loses electrons, becoming either a negative or positive charge and transforming into an atom or particle carrying a charge called an ion. When a cell is ionized, it may die immediately or survive but suffer severe damage, potentially causing DNA mutations. If those mutations are not repaired, the cell may undergo further mutations and eventually become cancerous. That's at low doses. At high doses, gamma radiation causes severe acute tissue damage, depending on the exposure dose. Victims may experience symptoms ranging from nausea, vomiting, diarrhea, headache, fever, cognitive impairment, and fatigue to death within days to weeks. It's also important to note that gamma-ray fission is usually secondary fission, meaning the nuclei rarely have so much excess energy that they are forced to release pro-gamma rays to become more stable. Instead, gamma decay typically occurs after other forms of decay, such as alpha or beta decay. Following an alpha or beta fission, the newly formed daughter nucleus is usually in an energetically excited state. This is when it releases gamma rays to return to a more stable state. Conversely, molecular level changes when gamma rays bombard matter can be used to alter the color of certain semi-precious stones, most commonly to change the color of topaz to blue. Gamma ray sensors using C2C137 and cobalt-60 are frequently used in mining, refining, chemical, food, soap, detergent, and paper and pulp industries to check the level, density, and thickness of materials, or to measure liquid levels in the water and oil industries. In the United States, gamma-ray container scanners began to be used, with the ability to scan up to 30 containers per hour. One important application of gamma radiation is irradiation. Simply put, it involves using gamma radiation to kill living organisms. Gamma irradiation is used to sterilize medical equipment, eliminate putrefying bacteria, and prevent the sprouting of fruits and vegetables to maintain their freshness and sweetness. Despite its carcinogenic properties, gamma rays are also used to treat certain types of cancer. Focused gamma ray beams, called gamma knives, are aimed at tumors from different angles to concentrate radiation on cancer cells while minimizing damage to surrounding tissues. Additionally, gamma rays are also used in the phosphor emission tomography technique for diagnosing certain diseases, such as cancer, cardiovascular disease, neurological disorders, and infections. Alpha particles, with 2 protons and 2 neutrons tightly bound together, carry a greater electrical charge, are heavier, and move more slowly than beta particles and gamma rays. Therefore, they interact with cells and tissues in the body much more easily than the other 2 types of radiation. According to some elders who said that humanity is inherently prone to sarcasm and teasing, due to its extremely short absorption range and inability to penetrate the outermost layers of the skin. Alpha particles are generally not life-threatening unless swallowed or inhaled. Once inside the human body, alpha particles, initially considered a harmful form of radiation, become the most destructive form of ionizing radiation. It is estimated that chromosomal damage from alpha particles is 10 to 1,000 times greater than the damage caused by an equivalent amount of gamma or beta radiation, which is on average about 20 times greater. Specifically, one study indicated that a certain inhaled dose of alpha particles carries a risk of lung cancer similar to that of external gamma radiation, which is 20 times higher. In the days when clock hands glowed with radium-based paint, many workers contracted cancer. To create beautiful brushstrokes on small surfaces, many artists licked their paintbrushes soaked in radioactive radium, an action that was not yet known to be extremely dangerous at the time. One example of a radioactive substance that emits powerful alpha particles is polonium-210. The amount of alpha particles released from polonium-210 is more than 5,000 times greater than that released from the same amount of radium-226. Just a few cans of polonium-210 can emit enough alpha radiation to ionize the surrounding air and cause it to glow a bright blue light. It is suspected of causing lung cancer and bladder cancer related to smoking. Polonium-210 was also used to assassinate former Russian intelligence officer Alexander Litvinenko in 2006. According to Wikipedia, after meeting with 2 former spy colleagues on the morning of November 1st, 2006, Litvinenko suddenly fell ill. On November 3rd, he was admitted to Vannet General Hospital in London before being transferred to the University Medical Center for intensive care. Despite all efforts to save his life, Litvinenko died on January 23rd. From the outset, a significant amount of the rare radioactive substance polonium-210 was found in his body. This substance was allegedly a sophisticated weapon used to permanently silence the Russian spy, who was then living in exile in the United Kingdom and working as a journalist, writer, and advisor to British intelligence agencies. Polonium-210 is described as extremely toxic. It is one of the most dangerous radioactive toxins to humans. By weight, polonium-210 is approximately 250,000 times more toxic than hydrogen ammonium. Just 1 microgram, or 1 millionth of a gram, is far too much to kill a pepper grower. In fact, it is believed that 1 gram of polonium-210 is enough to kill 50 million people and incidentally trap another 50 million. In other words, you only need 160 grams of polonium-210 for all 8 billion people on Earth. Fortunately, polonium-210 is extremely rare in nature. It exists in uranium ore, but in a concentration of only 1 part per billion, far too small to be mined. The most efficient way to synthesize it is by bombarding the bism-2009 isotope inside a nuclear reactor. This process transforms bism-2009 into bism-20, which then decomposes beta into polonium-210 with a half-life of approximately 5 days. Through this method, approximately 8 grams of polonium-210 are produced in Russia and shipped to the United States each month for commercial applications. Yes, the polonium-210 is like a very sharp knife. Besides using it to kill people, you can also use it to pick fruit, for example. Polonium-210 releases a large amount of energy during natural decay in the form of alpha particles, which can be easily blocked by a thin, lightweight material. Therefore, it is used as a compact and highly efficient heat source to power radioisotope thermoelectric generators and artificial satellites. According to calculations, 1 gram of polonium-210 can generate up to 140 watts of electricity. From 1969 to 1977, the Soviet Union equipped all Luno-C lunar rovers with polonium-210 heat sources to keep the internal components warm. Compared to alpha particles, beta particles are much lighter and also move faster, while retaining the same electrical charge. Of the 3 common types of radiation, Beta particles have medium penetrating power and medium ionizing ability. Although beta particles emitted by different radioactive substances have different energy levels, most of them can be blocked by a few millimeters of aluminum. However, this does not mean that the beta-emitting isotopes are physiologically weak and can be completely shielded by such thin shields. As the beta particles decelerate inside the shield, the electrons emit secondary gamma rays that have a higher penetrating power than the original rays. Interestingly, the white sheets use dense materials like lead to produce stronger secondary gamma rays. This means that for beta particles, using shields made of lighter materials is slightly more effective than the lead shields commonly used to block gamma rays. Speaking of lead, the reason it is widely used as a radiation shielding material is because it is very dense, meaning the lead atoms are very close together, making it very difficult for radiation to penetrate. Instead, the high-energy radiation beams continuously collide with the lead atoms and gradually deplete their energy. It's as simple as that. According to him, gold has a higher density than Chi, meaning that gold atoms are closer together than Chi atoms. Wouldn't using gold as a radiation shield be even better than using other materials? That's right. With the same thickness, gold's ability to block X-rays and gamma rays is definitely better than that of other materials. However, that advantage is certainly not enough to make people switch from spending. Gold, which costs only about the price of a cup of bubble tea per kilogram, can buy a Mercedes or BMW in the same price range. Returning to beta particles, because they're composed of charged particles, beta radiation interacts with matter more and therefore has a stronger ionizing effect than gamma radiation. Beta radiation is strong enough to cause burns similar to a severe sunburn. If inhaled or swallowed, radioactive substances that emit beta particles can also harm cells and internal organs. Conversely, the average academic penetration capability of beta particles also offers some advantages. Thickness gauge machines can use certain beta-emitting isotopes to control the quality of thin materials, such as paper. Certain isotopes, such as strontium-90 or strontium-89, are widely used in medicine for surface radiotherapy of certain cancers, such as eye cancer and bone cancer. Ironically, strontium-90 is one of the leading causes of bone cancer. According to the U.S. Nuclear Regulatory Commission, strontium-90 is one of several radioactive isotopes that tend to accumulate in bones when introduced into the body. That's why it's also known as the Munker bone seeker. They usually enter the body after consumption of contaminated food or water. Approximately 70 to 80% of strontium-90 is excreted, with the remaining 99% deposited in bone and bone marrow. The presence of strontium-90 in bone may cause bone cancer, cancer of nearby tissues, and leukemia. Along with the isotopes Cc, Cc-134, C-137, and isotopes iOS, iOS-131, strontium-90 is one of the radioactive substances that caused the most serious health impacts after the Chernobyl disaster in Ukraine in 1986. In short, gamma rays have the strongest penetrating power. However, because it has no electrical charge, it interacts with matter less than the other two particles. Alpha particles have the poorest penetration ability when outside the body. They're almost harmless. However, if inhaled or ingested, it becomes the most destructive form of radiation. Their large mass, slow movement, and positive +2 charge allow them to steal many electrons over a very short distance, causing greater damage with the same radiation dose. Compared to alpha particles and gamma rays, beta particles have a medium level of penetration and ionization ability. The problem here is that the decay chains of radioactive substances are often very complex. They don't just release one of the three types of radiation. Instead, they typically produce a mixture with varying proportions of all three radiations, alpha, beta, and gamma. You are seeing the main series of uranium-238 fragments. In this highly simplified diagram, all minor fragments have been omitted and gram fragments are not shown. And as you can see, it's still incredibly complicated. Similarly, we have the principal fraction series of thorium-232. To express the amount of chromogenic radiation absorbed that can cause harm and the probability of radiation-induced genetic damage in cancer, the unit CVT is used. Named after Maximilian R. Kvet, a Swedish medical physicist renowned for his work in measuring radiation doses and studying the biological effects of radiation. A CV is equivalent to a 5.5% probability of developing cancer that could lead to death. It is approximately the biologically effective radiation dose equivalent to about 1 Gray or 100 Ras. Gray and Ras are 2 units of measurement for ionizing radiation dose, where 1 Gray is equivalent to the absorption of 1 joule of radiation energy per kilogram of mass. To give you a better idea, on average, each person on Earth receives a free dose of radiation from Mother Nature of about 2. Vet, which is equivalent to 2.4 thousand of CVT, or about 0.24 are per year. I know you're not being secretive. Radioactivity is abundant in nature. The sun and stars shower Earth with a continuous stream of cosmic rays, like a steady drizzle of gamma rays. Earth itself, our sacred home, is also a natural source of radiation. Radioactive materials, including uranium, thorium, and radium, occur naturally in soil and rocks. The air contains radon, a colorless, odorless, and tasteless radioactive gas that makes up most of the radiation we receive from Mother Earth. Water on Earth contains small amounts of dissolved uranium and thorium, and all organic matter, both plant and animal, contains radioactive carbon and radioactive potassium. Even the fruit of the banyan tree, when you eat it, contains the radioactive isotope potassium-40. There's so much of it that if you ate about 35 million banyan trees at once, you would be exposed to an acute, lethal dose of radiation. Even from the moment you're born, you're already immersed in a dose of radiation, primarily potassium-40 and carbon-14, as part of your beginner's equipment. Therefore, exposure to natural background radiation is almost unavoidable. However, it's not so serious that you need to worry. To put it simply, using a single civet of radiation is enough to create a 5% chance of causing cancer and potentially leading to death, equivalent to 417 years of inhaling natural radiation. That is assuming this amount of radiation is cumulative. And in fact, I'm over 70 years old this year, and I haven't seen anyone live even a third of that age. So, Real Facts has just finished presenting the second part of the radiation brainwashing video. Please leave your comments below so we can discuss this topic together. As always, remember to subscribe to the channel and ring the bell to stay updated with new insights. And now, goodbye and see you again.